And now for our last construction, the angle bisector. So here's something we're going to look at. This is the perpendicular bisector construction. You're thinking, wait, we're doing angle. But first, let's take a look at the perpendicular bisector construction. What can we really say about a triangle ACM and triangle BCM? Well, I already know that these 2 points here, this segment and that segment are congruent. And because it's a midpoint, I know that's congruent to that. And I know, believe it or not, I actually know that this is going to end up being congruent. It has to be for Pythagorean theorem to work. So I actually know that these triangles are going to be the same size. It's going to cut it into 4 congruent triangles. And in fact, you may notice that if you connect A, C, B in this random point down here, you have a rhombus. But that's a side note. So if these triangles are congruent, then, well, I know that means the triangles are congruent. Then I can talk about angle ACM, this angle right here, and angle BCM. Well, that's just the triangle flip. So that angle is congruent to that angle. Okay, all right. So, and you're probably thinking, okay, wait, everything should make sense. So what does that mean? What's the important part? Well, how do they compare to ACB? Well, ACB, should be half of that angle, ACB. And this angle should be half of of ACB too, BCM. So that means that this bisector cut that angle in half. So if you were to look at any of these angles on the side here, the bisector, these perpendiculars, are cutting the angles in half. You're actually creating a rhombus. So we can conclude that perpendicular bisectors can actually be used to make angle bisectors if the endpoints of the segment are equidistant from the vertex. All right. So if these 2 points are the same length from the angle vertex there, then it'll work. So let's take a look at what strategies are used to bisect an angle. This is an angle bisector construction, and we will practice it in class. But you can still get the big idea. First, we're going to create a segment where both endpoints are equidistant from A. So the easy way to do it, you can set your compass to any radius and go ahead and mark your arc, which is this one right here. Then what we're going to do is bisect segment BC. So I could connect these two. And so to bisect, I just do a circle around B and a same size circle around C. And where those intersect, that's my bisector. And see, it goes right through the angle. So for further reflection, did you recognize the shape created by the 4 points used in a perpendicular bisector? Hopefully you heard me say it. And here's something that kind of goes beyond. How do you think you might construct an equilateral triangle? Think again of circles. How could you put them together so they made an equilateral triangle? And how do we use the property of equidistance and congruence to construct the different geometric objects?